Hello. Today we're going to start discussing on partial fractions. So this is another integration technique that we do using this particular technique of writing the function as fractions and then trying to integrate. Now, before I actually give you the problem that you will see in this section and show you how to solve it, let me start with a little bit of concept first. So let's say I ask you to integrate something like this, 1 over x, and then what do I want? Minus 2 over x plus 1. If I ask you to integrate this function, will you be able to do it? Well, not too bad, right? Well, you can separate them into two integrals. They're two different functions. This is 1 over x, and then minus 2 is a constant, you can pull it out, and this is 1 over x plus 1, right? And then you know the answer, right? This one is ln, then minus 2, this one is another ln of x plus 1, and you're done. See how easy it is, right? It is easy because the two functions that you had to integrate, they were already separated in a way, okay? They were just two separate functions added together. But imagine what if your function, the problem that you had to solve, was not given in this form. Instead, let's do a little algebra first. So if I add these two together, what do I get? Okay, I get a common denominator of x times x plus 1, and then you cross multiply. So x plus 1 minus 2x, and that is, what is it, 1 minus x? Over, let's multiply this through, x squared plus x. Okay, so the type of problem that you will be doing in this section are going to look like this guy. This is a rational function, polynomial over polynomial. So the problem will be you have to integrate 1 minus x over x squared plus x dx. Now how will you do that? Well, usually with a rational function, we might want to do a u substitution. If you take the denominator to be your u, and then let's take its derivative, what is it? 2x plus 1. We don't have that, 2x plus 1, right? So it's not that simple just by taking a u substitution. And this is probably a simple enough fraction, but you can have much complicated looking ones. But here's the deal, right? Look. This function that now I'm asking you to integrate is exactly this original function. See, they're equal. So if we knew that we can somehow take this guy and break it apart into these two, then the problem will be much simpler to solve. You will say, oh, guess what? This is a complicated looking function. I don't know how to deal with that, but I know this function looks like 1 over x dx minus 2 over x plus 1 dx. And then I can solve it. I know the answer to this original function. The answer is ln of x minus 2 ln of x plus 1. So do you understand my point? My point is that when all of these different fractions are combined together, it's much harder to solve. But if you recognize that, oh, this is a rational function, I might be able to split it up into partial fractions, then I can solve it easily. So that's what we're going to do. So the forward direction is easy. If the fractions already given to you is easy. But the harder part, the challenging part is to do the algebra and know how to change this original rational function into some fractions. And once you do the fractions, then integration is much easier. So that's what we're going to do. Okay, we are going to learn this method of partial fraction, how to change a rational function into partial fractions.